Good evening, everyone, and welcome and thank you for attending this Raising the Bar Perth social event. My sole job tonight is to introduce our speaker. Pattiaratchi is a professor of coastal oceanography and has been at UWA for 30 years. He's played an active role in examining climate change effects in coastal regions of Western Australia, and particularly in terms of ocean currents, wind and wave climate, sea level variability, coastal flooding and beach stability. And he also has some pretty cool toys if you go and visit him, and you can have a look at his ocean gliders. Terry will talk about the role oceanography plays in predicting the possible drift of debris from the MH370 plane disaster. So please join me in welcoming Terry to the stage.
I'm an oceanographer. I don't know anything about aircrafts. So I'm only going to talk to you about the oceanography and how the oceanography is trying to help to find out what happened to MH370. So I'm going to take you on a journey which is sort of partly personal, of sort of my story of what happened. So on the 8th of March, we actually, the plane was going from Kuala Lumpur to Beijing, and as you all know, it disappeared when it was crossing the airspace from Malaysia to Vietnam. Now, my first involvement happened the next day. I had a phone call from one of my former students who was working at University of Malaysia in Terengganu, which is the starting point of where they started looking for the debris from the MH370. And he says, Charlie, they're all asking all these questions from me. All the press wants to know what happened. Where would the debris end up? What I'm going to tell them. So I actually told them, you know, this is what will happen, and gave a very wide explanation. And then, of course, a couple of days later, it was not in the South China Sea, but in the Andaman Sea. So I thought that was the first stage. Then I was at a meeting in Adelaide, and waiting for my flight to board, and then my phone went and I answered, and then a journalist said, I'm so and so, they told you, you're the person to speak to. Now they have changed the search area to off Perth. What do you know about this area? So I said, oh, if it's that area, well, you know, it's very deep, very cold, and it's close to the roaring 40s, very rough, big waves. And that was basically what I said. And then, as you know, you got on the plane, you switch your phone off, and then I arrived back in Perth. 3.5 hours later, I put my phone back. I had 33 missed calls. So now I was thinking, what has happened? Because what happened was that that journalist, in the meantime that I was on the plane, had put my quotations, and of course everybody then wanted to speak to me. And all they would say is, can you tell us about it? Well, I said, well, you know, the same thing. We're in the roaring 40s, it's very rough, it's very cold, it's 4 kilometers deep, it's just like somebody in the fridge, but 4 or 5 degrees cold down there, very dark. No? So this was the story that I was telling all the time, but then, of course, everybody wants to know from my mouth exactly the same thing repeated again. And then, as you know, virtually the whole of the world's press descended on Perth because they started doing the searches from RAF piers, and they were flying out every day. And then, of course, all this press wanted to know more stories. They couldn't actually just camp out in RAF piers and just wait for something to happen, so they started looking, and of course, sooner or later, they came to my office, my lab, there were queues outside my office, and I'm actually giving all these interviews and whatever. And then suddenly I told my colleague, he said, you know, surely, we have been doing this work for 20, 25 years, we can do a lot more than saying it's rough, it's cold, it's dark. So let's use our knowledge to try to help or see what we could contribute. So that's basically how it started. So, what have we been doing in that 25 years in the oceanography that could help MH370? Okay? So, we all know about a message in a bottle, right? So, let's imagine this is your message in the bottle. You go and put it in the ocean. Yeah? There's a little girl just on Essex, in the mouth of the Thames estuary in London, went and put a Coke bottle in the water a few years ago. Where do you think it ended up in? Anybody know? Just south of Geraldton. So from London to Geraldton in 6 weeks, a Coke bottle. Would you believe that?
No.
It did happen. So when you actually look at the system and then look at the currents and the winds, there are two critical areas that the Coke bottle has to jump, if you like, but it actually followed the ocean and the wind. Another story. I'm going to digress a little bit as we go along, keep you entertained a little bit. Not a comedian, but I will try. So again, so the TV, of course, it's a big news, right? Because, as you said, wow. And so the person who came to interview me said, we have this wonderful animation that the BBC said, and it said that the bottle came from Britain, came down the Atlantic, went to the south of South America, came across the Pacific into Geraldton. And I said, no, that's wrong. It's going always in the opposite direction. I said, just think about the old sailing ships. They came down, South Africa, came across to Western Australia. They didn't know there were lots of reefs, so a lot of them got shipwrecked. And then they went north to Indonesia. That's the same way that bottle came. But of course, they don't want to give a good story and a good animation, right? So guess what they did? They put the animation behind me and my voice in front, while the animation is saying the bottle is going one way, and I'm saying the bottle is going in the opposite direction. So, but that is a story. Now, another one. This is a little bit, I'll talk a little bit about grisly things as well. Most of you probably heard about the severed human head which ended up and washed up on Rottnest Island a few years ago. So they were saying the police was sort of, they wanted to know where it came from. And they were kept saying, it says, it came from Rockingham off Garden Island. And I told them, I said, no, it doesn't come from there, because if it actually came there, it wouldn't have got to Rottnest. It has to come from further south, north of Mandurah. And sure enough, we were able to pinpoint by looking at the currents where it may have originated from. So that's a forensic oceanography. But it's the same principle. Message in a bottle. Anyone from Bustleton? Yeah. No? So Bustleton has a big problem. Has been for several years in Port Geograph, where they built a canal system and a canal estate which was collecting seaweed.
Yep.
And that seaweed, rotting, smelly, very bad, and the developer went bust because he couldn't sell the houses and the land because the smell was too bad. So then Department of Transport came to us and said, can we solve this problem? We want to know how we can design so that the seagrass wreck does not accumulate. So we built a computer model. This was a seagrass. So what I'm trying to show you is that whether it's a human head, whether it's a bottle, it's the same principle. We want to basically track a parcel of water, whatever it is in time. And that's the oceanography. But it's not that easy. So if I take this bottle, and now we say, I can't use two hands, so let's say where my hand is where the water level is, right? So now, when the wind blows, the water moves, and then it moves. But there's also a component of the wind on the top. So it actually goes according to the wind. So we have to take two things into account. But then we have waves. And the waves make the bottle or the object go round and round, but every little wave crest, it will go very slowly in the direction of the wave. Okay? So that's sort of some of the things that we have to take into account when we're looking at the system. But one of the most difficult things to do is to say, well, the wind is blowing, this is going in the object. Which way does it go? Does it go left? Does it go right? So, let's think of an experiment. Let's think that all of us went to the beach, right? This is terrible, nice day, we all went to the beach, we went for a swim. We took our shoes off, and then while we're on this, having our swim, this big wave comes along and takes all our shoes back to the ocean. Now, a few days later, we go around the beach, we start collecting our shoes or slippers or whatever we have. Do you think anything different that we will find with the shoes or slippers? So now I'm looking at the ocean, my left, my right, and I'm going to go and collect shoes all over. So these are the ones which were all in one lump, they were taken out and come back. Do you think I will find something unusual? What do you think? Sorry?
They've moved from where you went into the water.
Yeah, they're gone out and then come back.
But they've come, yeah.
But what if I said that all the shoes that I found on my left-hand side were left-footed ones, and all the ones I found on the right-hand side were the right-footed ones? Would you believe that? No?
Shape of the shoe.
It's true. You know, in many parts of the world, you go and find, you will only find a right-footed shoe or a slipper. And in the other beach, you will only find a left-footed one. That's a fact. Why is that? If I take my shoe, now the shoe floats upside down. Okay? So now look at the shoe, the shape of the shoe. So when the wind blows, it'll blow in one direction. The other shoe will go in the opposite direction because of that shape. So the next grassroots thing, there's a beach in the between Vancouver and Seattle, the ocean between US and Canada. There's one beach which only every year receives a human foot and only a left one, and on the other beach only a right one. If you don't believe me, go home, Google and say, do you actually see human foot Canada, and see what you get. It's true. Same reason. So those are the things that we have to take into account when we are looking at the ocean currents. Right? So we want to know how these ocean currents affect whatever is transporting. So we have to take into account the shape, how much of it's sticking out, how much of it's underwater, what are the waves, what are the currents, the direction that it is going in. All of that we have to take into account. Right? So we now have to build a model that we use in the globally that tells us what are the currents are. Okay? So it tells us, it takes all the satellite images, it takes all the satellite data, all the ship data, every single piece of data that we can have, we can actually put into those models to get an idea of what the ocean currents are. It's no different to what you actually see on the TV every day with the air going around. We have a similar thing to the ocean. So that we actually have every hour. So now we actually have to put what we call particles in the water, maybe your bottle, maybe anything that you can think of, let's say an orange or anything, and then we're now going to track these parcels of water according to the currents, the wind, and the waves, and we want to know where they end up. So, that's the oceanography part. So now we can go back to the MH370. So what happened with MH370? It was in the South China Sea, as he said, then we went to the Andaman Sea, and then a satellite, which is run by a company called Inmarsat, was actually receiving signals from the engines of the plane. And roughly it was receiving every hour. So imagine the satellite high above the ocean, stationary, and it's actually saying, what is the distance to my plane? So that gives us circular bits of an equidistance from the ocean. Can't be on the other side because it didn't have time to get there. So it can only be on this side of the ocean. The seventh one was the last one. So that's what we actually have, an arbitrary line, and in fact that line is 20,000 feet in the air, which is the time that we have. So we have a line, but we don't know where along that line the plane might end up in. If the plane was going very slow than normal, it may have ended up further north, because it wouldn't have come further south. It was going much further, it was going faster, it would have ended up further south. So this is where we have the issue. We know where it could be, but we don't know where this, and this length could be almost 1,000 kilometers long. So this was the, so then what we had was, we are academics, so remember I said, oh, what more can we do? So we did simulations with what I just said, we did computer models, we looked at where the drift ended up in, and all of those, whatever came anywhere along that seventh arc, ended up in Madagascar, in the Western Indian Ocean, and I know that. We put lots of satellite track drifters, even if I put something off Rottnest, ends up in Madagascar. A few years ago, a little dinghy came undone north of Geraldton, ended up in Madagascar. Anything which actually comes from here ends up in Madagascar. Now, we know that, because all of the ocean gyres, ocean basins have what we call an anti-clockwise circulation. So the water from offshore Perth will go north, will go west, will go south from South Africa and come back again. So it's a big circular motion of the water. So anything here will go up, go there, and end up. So that's what we call the ocean gyres. And in a way, we don't really need a computer model to say that, because that's our basic knowledge. It was then interesting to say, so we, as academics do, we wrote the paper up, we presented it at a conference, that was in August 2014, and we forgot about it, basically, in a sense. Not really forget about it, but nothing would happen, because then, as you know, the official investigators was the ATSB, and the ATSB also had their own advisors about the oceanography, and their advisors were telling them the debris, if there was any, will end up in Indonesia. And then I was saying, it can't happen. Because as I said, anything which goes from here couldn't get to Indonesia, because that strong current will take it to the west. So, nothing really happened. So, but then, an impasse. So, 29th of July, 2015, my phone goes at 5 o'clock in the morning, as my wife said, don't leave your phone on next to your bed. There we go. 5 o'clock in the morning, woken up. Oh, they found a piece of an aircraft in Reunion Island. What can you say about that? Oh, okay. So between 5 o'clock in the morning and 5 o'clock in the evening, 12 hours, I had given more than 100 interviews. Because everybody wanted to know, because here is the official prediction was the debris was going to be in Indonesia, but here I was saying that it was going to be in the Western Indian Ocean. We had already modeled, and so everybody wants to go. You know, at UWA we had a press conference with about 10 people, number of people. So I asked them, you know, I said, if I stood here 12 months ago and told you that the debris would end up in Madagascar, you would have laughed at me. None of you wouldn't even come to listen to me for the press, right? Because it's not possible. But that's what happened. So then, at that time, now remember, now we've gone almost 18 months, 2 years. So we, rather than, remember I told you that we cannot actually figure which way it's going. So what we do is that we seed a lot of particles. In fact, we do 50,000, and we give random directions. And then we actually follow them. So imagine we're now putting the wind information, the wave information, the current information, 50,000 particles, each one of them, and we got to track them where they are every hour. That we can't do on a laptop or a desktop. But when we actually had a lot of, obviously, the publicity, the director of the Policy Center rang me. The Policy Center is a supercomputer in Perth. At that time, it was the fastest supercomputer in the Southern Hemisphere. Okay? He says, would you like some time to do your simulations on our computer? We will give you time on our computer. We will also give you a programmer to adapt our models to a supercomputer. Oh, wonderful. So then what we did was say, okay, remember what I actually said at the beginning. We have this 7th arc. If the plane was going fast, it would be at the bottom. We knew if it was going slow, it would be at the northern end. But we also know how long it took it to get to Reunion Island. So we said, okay, we will actually put all the way along this line, and then we say, how long will it take for each one to get to Reunion Island? So what we showed was that if it was right in the south, it wouldn't have got to Reunion Island in the time that the flaperon was found. If it was in the northern end, it should have taken 3 months earlier to get there. So there was a sweet spot in between where it would get there. So that was the one that we actually said most likely the plane was going to be. The next thing happened was that, again, we actually was showing this, and then there was a person called Blaine Gibson who contacted me, and he was working a lot with the next of kin, trying to help them, and as being an individual. So he came to see me and said, Chari, you know, you have to tell me where I can go and find some debris. So I told him, you have to go to Madagascar. And he had this thing that his aim in life is to go to every single country in the world. Right? That was his aim. So I said Madagascar, and he says, oh Chavi, I've been to Madagascar. So I said, okay, go to Mozambique. And I could say from my model where in Mozambique he could go. So, okay, I will go. So, goes to Mozambique. Within 3 days, he found pieces of debris. And then, like that, then he said, oh, Chari, I've just been in Maldives talking to the people who may have seen the plane. Where should I go? Reunion Island, plane, Madagascar. So off he went, and he found something like 15 pieces. So altogether, he found 27 pieces from MH370, which were predicted from our model, where I was telling him where to go, and he was actually finding where it was. But he still did that. So now, you know, there's a lot of things, and we can actually explain. A lot of people saying, well, if it was so close, why haven't we found any in Western Australia? They all went the other way. If we do find in Western Australia, they're the ones who would come back again. So they've been to South Africa, they haven't grounded, they come along the Southern Ocean, and then they might come. The next few months, few years, we never know. So, what was this? So now, during the same time, the ATSB and the government of Australia contracted a company called Fugro to go and look at the seabed, to try to survey the seabed, to try to find out where the plane might be. So they defined an area which is to the south of where we were saying most likely. And so what they remember, I told you that arbitrary line and 20,000 feet. And now the problem is that did the plane fall directly south? Did it actually go different? So how far from this line could the plane be? So this is again not my speciality, because this is a aeronautics problem. They defined that it would be something like roughly 50 kilometers each side of this 7th arc. So they defined this box about 300 kilometers long and 50 kilometers wide, probably longer. Anyway, roughly the size of Tasmania. Okay. So, and they took almost 3 years to complete that area. So people ask me, why does it take so long? You know, because you're towing something 4 kilometers down, you can only go at about 20 kilometers an hour. Now imagine that you are going and looking at every single bit of Tasmania at 20 kilometers an hour. It takes a long time. Imagine you're doing that closing your eyes. It takes even longer. So that's one. So they basically completed that area and they didn't find it. And then we actually had what's called the Oceanography, which is a company, a private company, who basically made a proposal to Malaysian government saying, we will go and look for it, you don't have to pay for us, but if you don't find it, you have to pay us. So they of course, you know, they did their due diligence, they got a lot of people to London, they flew me to London, and we all sat around the table and we defined, you know, what is the most likely area. So they did, but they used, you know, in like 2 years, the technology increased so much. I told you Fugro took almost 3 years and to do that particular area, and Oceanography did it in 3 months. And what they did was they basically had, rather than one, they had 8 autonomous vehicles. They were just chucking it, they were doing it on the surface, and then they would pick it up. And they then stopped because the weather got bad. So the final thing now is that they might go back up. They might do the risk again, but they have to put their money up. But the unfortunate thing is that there's some people saying it's further north, which is the avionics people saying that that's where most likely it, while the oceanographers are saying, no, it can't be there, it would have got there far too quicker. So even if they start a new search, they would not be definitive in the area. So at the moment, what we are thinking in terms of oceanography point of view is that that area that they defined, the 50 kilometers either side of the 7th arc, is probably too narrow. So it's probably wider, because the oceanography can say something, but we cannot actually say it's here. We can only take the results from the avionics, where that line is, which the particular area, and anywhere that we put possible debris, they will all end up in the Western Indian Ocean. So really, that's where we are in at the moment. So, that's my story. And so, I'll be very happy to answer any questions.
The autonomous vehicles are used for scanning the bottom of the ocean. How long can they stay down?
They stay somewhere between 50 and 60 hours. So it takes about 4, so remember we are in 4 kilometers. So when it actually puts in the ocean, it takes about 4 to 5 hours for it to go down. Then it will be a fixed, I think they were using 50 or 100 meters above the seabed, and they would scan it, just like your lawnmower. And then when the battery comes back again, another 4 hours to the surface, they bring it up, take the hard disk, put a new hard disk, take the batteries, put a new battery, chuck it out again. So they're continuously working with 8 of them, that cycle.
Have you seen any change in the level of interest for oceanography since this story has come out? Are your first year classes filled with students now, or has there been a change that you've noticed?
I haven't sort of noticed that, but what I actually notice is that people know what oceanography is. You know, really, MH370 has given an appreciation to what an oceanography do.
Do you think it will still be relatively one-piece, or do you think because the ocean is so powerful, you'll just have to split up quite a fair amount?
Just look at history. Titanic is still there. 100 years ago. They found HMS Sydney more than 50 years later. So the bottom of the ocean is very quiescent. Imagine filling this room with water, something like 2 degrees or even 0 degrees, and it's there forever. What is there, doesn't go anywhere. So somewhere when we have much better information, much more efficient way of scanning the seabed, we will find it. But I don't know how long it will take. As I said, you know, something that we took 3 years to do, we can do in 3 months now. Maybe the same area in a few years can be done in a few weeks. And if that comes to it, we have much more better way to find out.
Yes, I'm interested in the supercomputer that you got access to. What other kinds of compute problems does that work on?
The main reason that computer is here, although now it's about the second or third, it's not big enough. They're now building a new one. It's all about the radio astronomy, the square kilometer array. So we are benefiting from that. That is the main part. But there are a lot of people do with crystallography, with geology, and we use a lot of oceanography too.
You haven't found that playing back, have you found anything else cool or interesting along the way?
I haven't, in effect. But the area, I mean, I don't have much interest on the seabed per se, but the geology of that area, nobody's ever known. So people sort of don't like me saying it, but it's the truth. But we know more about the surface of the moon than the bottom of the ocean. See, the moon is not covered by anything. We can look on from Earth and we can take a photograph and we can map it very quickly. The ocean, you can't do that because it's a lot of water. So you can only do this slow mapping. We haven't mapped at all, maybe about 20%. And that 20% is areas that people are interested in exploring for oil and gas. So there's other areas where there is nothing and nobody has interest, has not been looked at. So in that swamp that I was talking about, they found volcanoes, old rivers, mud volcanoes, earth slips, enormous amount of different features that we didn't know. The vertical, I think there was one wall that I saw was something like 2 kilometers sheer vertical wall for about 100 kilometers. So if you pull the plug out in the ocean, you see some amazing things.
Because you've found so many pieces of debris now, and that to me is like data points. And we've been obviously observing the weather patterns, ocean wave patterns throughout the past like 2 or 3 years. Wouldn't you not be able to actually just backtrack? And obviously it's timestamped kind of the data points, and wouldn't you not be able to just backtrack and then help them to find the source of the aircraft? That's actually question one. And the second question was, well, this survey and seabed search costs a lot of money, and I'm in the offshore industry, so it costs money. And how is the funding at the moment? And like that really determines, how much longer you can actually keep on going doing this.
The first question is easy to answer. In fact, there was a German group who did exactly that. And they say, oh, this is where reunion is, we'll work backwards. And all of that ended up in Indonesia. And they said, there we go. Indonesia, that's where the plane is. Big problem for that. I will give you an example. Let's say we have a river and lots of tributaries. And we put particles in all of those tributaries. Where would they end up? At the river mouth. If you go backwards, they will all go on the main river. None of them will go up the tributaries. So when you go backwards, the backward tracking only goes in the direction of the main currents. So the main currents, as I said, is from east to west. So it will go up end of the other system. I forgot something to tell you. So remember I said the ATSB said that the debris would end up in Indonesia according to their oceanography. So when we found, when they found the flaperon and we had predicted directly, of course my phone is going, what are you doing that we are doing different? It worked out that they made a simple mistake. They swapped the components of the wind in their model. So they made a basic mistake, which they would never have found if they haven't found the flaperon. So, the answer to the second question is a little bit different. The first thing, how much value would you put to a life? What is the value of a life? This gentleman here is a pilot, and he was telling me, we want to know what happened, because it is an unknown. Obviously, there is a limit to where we would actually go and not look. At the moment, initially, yes, there was a lot of money spent. The last time with Ocean Infinity, the company itself actually sponsored themselves. Why did they do that? They got so much publicity, that ship is booked for the next 5 years, right? Because they demonstrated what they could do. So another company is going to come along and say, we'll do it. So it is a part of a commercial system, part of trying to find the unknown, bringing closer to the people who have lost their loved ones. It's a whole lot of complex answers that has to go through.
So you spoke about Titanic and HMAS Sydney. So those vessels are relatively intact, damage or iceberg damage, versus an aircraft hitting water at very high speed. What makes me think there's a wreckage to find?
There are lots of theories on that as well. A lot of people initially say, oh, there was no debris found, so the aircraft must be intact at the bottom of the ocean. That was wrong. We know that it's not wrong. On the other hand, what you also have to say is that the big items are still at the bottom of the ocean. The big items, the landing gear, the engines, fuselage, big pieces of the fuselage. You know, the two pieces have been found, the longest is that long. Out of that 27 pieces, the other 25 pieces you can actually put in a briefcase. In fact, Blaine with the next of kin brought 4 pieces to show me before he took it to Canberra. They're just small pieces. So those are the ones which have been floating, but all of the big pieces are in the bottom of the ocean. And they also have found that they obviously, the aircraft investigators, they have looked at lots of, because they built up a database in things like that, all of the previous crashes which has happened in the ocean and in the deeper ocean, the debris field is within 2 kilometers. So everything's basically almost in very small areas.
Would any tectonic activity actually affect where that goes? So maybe it occurred the year after?
We're in an area where the last tectonic activities was millions of years ago. So nothing will happen. Remember what I told you? It will take about 4 hours for those autonomous vehicles to go down. So plane debris would have been roughly the same time, maybe 4 to 5 hours to travel that area. With our case, we take into account with a random one. So we say, okay, we surmount it out of the water, so 10% of the wind will act on that, maybe a little bit more, 20%. So we take that, remember I said we actually take 50,000 particles. So each one has a different system that we add to that.
So when you do an analysis of ocean currents, do you take the upper surface current, or 10 metres down or a kilometre down into consideration, so to speak?
So in what we call the drift modelling, which is what we're looking at, things which are drifting, we take the top 1 metre. So that's what we're doing it. So in the top 1 meter is actually the hardest to model because we can't make measurements. So, then that's the one, any buoyant, particle, so you're probably aware of what happens to plastics. All the plastics are there. So another one that we do to find out where the plastics go, that's the same modeling that we do. The top 1 meter.
Thanks again for attending. Cheers.